In 27 minutes, I'm here for you all the way until the next period starts. The thing that I feel most students want to talk about is the rule of 70 and the jar doubling time stuff. I do plan to do that today, but I want to make sure that I'm not skipping either vocab or other stuff. That can be done really quickly. So yesterday we did the 1.1 and 1.2 vocab. In 1.3, does anybody have a vocab question? There's only one thing I wanted to add. Vocab on 1.3. Something I'd like to add. The steady state equilibrium is confusing to many students. The public often says that nature is in balance, or we have put nature out of balance, or we have to get back to balance.
Dynamic.
Yeah, I want to remind you that balance implies this perfect state, some sort of a universal definition of order. And life on our planet doesn't follow any rules. There is no balance. Nobody's in charge as far as we can tell. You ever notice how seesaws are always moving to one extreme or the other? Which means on average a seesaw is always in the middle. You guys get that? A lot of times people say, hey look, the deer and the wolves, those populations are in balance. Nature is harmonious. Don't disrupt the balance between the deer and the wolf. But that's a stupid way to look at the planet. Because remember, the deer and the wolf are not in balance. They don't meet on Sundays and come to an agreement like, can you guys eat 3 deer and we'll make sure one of you gets hit by a car so we can stay balanced? There's no order. There's no perfection. It's not like everybody agrees on how deer and wolves should be. Instead, watch. If the deer become populated, then it gives more food for the wolves, so wolf population grows. So with a lot of wolves, they hammer all the deer, which means that the wolves will all starve, which means there's no predators, so the deer come back, which means with a lot of food, the wolf population will grow, which means with a lot of wolves, the deer population will drop. And so there's this constant flux. They're never in balance. Like a seesaw, when you step back, it looks like, oh my God, there is this harmonious equilibrium to life. But no, there is not some perfect state of natural balance. It's actually quite the opposite. It's called a steady state equilibrium, like a seesaw. On average, it's in the middle, but it is a very dynamic system. Everything changes. We have to remember that life is not a static, harmonious, uniform, still system. Life on Earth is exactly the opposite. It's chaotic and messy, and in the end it looks balanced because that's the outcome of a big struggle that's ongoing. This seems like semantics now. I know I'm boring you. This will come up all year. You'll see what I mean. Okay, and then the study goals yesterday. Where did we leave off? Did we talk about the crop circles?
Yeah.
Did we talk about?
That's where we left off.
Okay, we talked about measurement, number 12.
No.
Remember that with better tools, you get better measurements. There's no perfect tool, so there's no perfect measurement. And this is something you probably learned in chemistry and in the 7th grade. Yeah, we did that?
No, we didn't.
Shut up. I don't know. Either you passed out for a moment. You have low blood pressure?
No.
Okay. Or maybe my good looks distracted you and you started to daydream instead of... That happens all the time. Don't worry, bro. It's natural. Okay. So we did do number 13 about how the scientific method doesn't really apply to the Earth.
Yep.
What did you say?
We're living in the experiment, so to
We
speak.
did it yesterday. We didn't do it. Yeah, we didn't do it.
So if we ended at 13...
Can we use those?
No.
I don't believe it.
Stay later, I'll talk to you. It's no problem, but I got to focus on them. We have a limited amount of time. 14 and 15, I've got nothing to add unless you had a specific question. Specific questions about 14 or 15? Then without any specific questions, I'm moving on to 1.3. I want to talk about, yes?
Can you reiterate negative and positive feedback?
Absolutely, because this is a 3-star issue.
Yeah.
Students mess it up all the time. It is number 17. Imagine I tell Graham, hey Graham, that's a really cool t-shirt, man. That's a positive comment, right? I gave him feedback on his clothes, and it was positive. Or I tell Hannah, dude, that sweater, bro, kind of out of fashion. Shouldn't wear that sweater anymore. I don't know if it is, I'm sorry, I'm not trying to talk crap. But I mean to say that that sounds negative. This is the way we use positive and negative in day-to-day conversation, like positive is a compliment and negative is an insult, or positive is something that's good for us and negative is bad for us. So like a balanced diet is positive and cancer is negative. I got to remind you, positive and negative feedback are not value judgments. You can have positive feedback of bad things. Because positive and negative is not like in English where that means good or bad. Instead, what's a good example of positive feedback, someone? How so?
The fire will start and it will dry the wood and it will cause it to spread.
Yeah, that's absolutely right. You know, the fire can't light a tree right away because trees have moisture in the bark, which is fireproof. As a matter of fact, a tree at the base of a fire will often go out. But if the tree picks up enough momentum to generate a lot of heat, that heat will dry out the tree. So when the flame touches the tree, now the tree can light. And when you light a tree on fire, you give off a lot of heat, which will dry all the stuff around there, and now it can burn, giving off more heat, which dries more stuff. So watch the definition. The outcome of the system causes more input to the system. Fire makes heat, and heat causes more fire in that system. That's positive feedback. It's self-fulfilling or self-reinforcing. Snowball effect, where the snowball picks up more snow, so it's heavier, so it rolls, so it picks up more snow, so it's heavier, so it rolls. The outcome causes more of the same. Positive feedback is also known as more of the same. Yeah?
Is population increase in a confined area?
Probably not, and I'll show you why. For a while it might be, and eventually it becomes negative. It's a tricky question, and I can explain why in a minute. But let me do a negative first, and I'll come back to yours. Remind me if I don't. Now, what's a negative feedback?
The balance between a signal and then a response that channels it out.
Right, where the outcome stops the cycle. So the product prevents more of that. That means self-regulating. For example, there's another negative feedback example of a fire too. If a fire gets hot enough, the ashes rise on a column of hot air, where in the atmosphere, those ashes become condensation nuclei, make rain, and the rain puts out the fire. You guys know that? That lightning strike fires often put themselves out because the ashes go into the moist cloud and provide a place for the condensation to start, and then the rain gets going. So in the Sierras, during the summertime, thunderstrike fires often put themselves out. The outcome of the fire is the ashes that make the rain to stop the fire. You'll notice that fire did not make more fire in this case. In the second example, fire prevented more fire by causing rain. Negative feedback, because it's self-regulating. The output blocks more of the same. That's negative. Self-regulating. Here's an interesting thing about population. With just 1 or 2 people around, population grows pretty slowly because they don't have a lot of choices, and when one of them is pregnant, there's not a lot of things to select from. But as the population starts to grow, there's more potential for good relationships. So there's a certain critical mass required, and then population really gets cooking and really gets cooking. And with more people around and more people to breed with and more babies around, everybody's inspired to have more babies, and sexy pregnant women make everybody feel more like making more sexy pregnant women. So for a while, population growth makes more population growth, but eventually, when that population growth starts to limit the resources per person, population growth will crash, and that's the negative feedback part.
Will that happen in our society? I mean, our resources are pretty low already. I mean, I don't.
It follows to reason that at some point our population growth would start to self-regulate because we're starting to run out of stuff.
Yeah. Okay.
You can see that with bacteria in a jar. Their population size picks up, and then when they start to limit resources, it starts to go down. So it goes positive until it goes negative. Population growth makes more, makes more, makes more, makes more, makes less negative, makes less, makes less.
Is that from people dying out or just the stop of reproduction?
You could say it's from the accumulation of bodies inside the jar, from spread of disease, from conflict over limited resources. More density makes more disease spread. I don't know, I can imagine a lot of examples. But you see what I mean, that positive makes more and negative makes less? Did I answer your question about this one? Can I clarify for anyone else, or am I moving on? Yes?
So in the textbook, it gave an example, increase in temperature followed by responses to decrease in temperature. Do we need to know like the biology of it, like vasodilation or anything?
No, because this is not a class about muscle dilation.
Okay.
That was just one example that shows you the very explicit definition, and you've definitely got to recognize it when you see it.
Okay.
If the outcome makes more, if it's something that encourages itself,
Okay.
snowball effect, positive. Remember, even if it's a bad thing, for example, some cancers, once the tumor grows, will block blood flow, which makes it easier for the tumor to grow. That means that cancer can run away and make more cancer. That's not a good thing. We don't like growing tumor, but it is positive feedback because it's more of the same making more of the same. Questions, or am I moving on? Thank you. Moving on. I can go to number 18 because this is the other 3-star topic. Please look up. There are only 2 variables. There are only 2 variables. If I have $100 in the bank at 3%, I have $100 in the bank at 3%. How long will it take for me to have $200? Some of you are like, oh yeah, I know Per, just give me my calculator, but you can't use your calculator on the AP test. Now how am I going to cheat? There's this really handy rule called the rule of 70. 70 divided by the growth rate as a percentage equals the amount of time it takes to double. It's a general rule.